So moving on to question 2 now. We're dealing with complex numbers. So we have the complex number z1 and the complex number z2 here. So part A just asks us to express z1 in modulus argument form. So how are we going to do this? Well, straight away we need to work out the argument and the modulus. So the modulus is probably easier to start with. So z1, remember to work out the modulus, we're just working out the magnitude in theory. So we're just going to square minus 4, we're going to square minus 3, and we're going to take the square root of that. So what that will be, is going to be the square root of minus 4 squared, so that's 16, plus the square of minus 3, so 9, and then we're going to square root that. So 16 plus 9 is 25, so that's the square root of 25, which is 5. So that's the modulus straight away for z1. Now we need to work out the argument. So imagine you was to sketch z1 on an argument diagram. It's going to be in the bottom left quadrant, right? If you do like a basic sketch, you're going to go 4 across here, minus 4, and we're going to go 3 down. So it's going to be somewhere like that, right? So when we're in that quadrant there, straight away, remember it's minus pi that we're going to add on to our inverse tan. And our inverse tan for this one, so arg z1, well, it's going to be tan inverse. And you've just got to be careful of the order that you do the tan inverse. And the way I'd advise doing this, guys, is to draw a sketch. And in this case, it's going to be 3 over 4, 3/4. And then don't forget, we subtract pi off at the end, minus pi. So do this, make sure you're in radians, and what do we get? So we get minus 2.50 for that. So that's my argument there. But now we need it in modulus argument form. And that's the 3 side of first, so that's fine. So let's put it in mod arg form now. Let's do that. So z1. Hopefully I'm going to have enough room here. So it's going to be 5, because that's the modulus on the outside. And we'll have cos minus 2.50 plus I sine minus 2.5 again. I'm just going to put 2.5 like that. And then that's it, we close the brackets there, so it's I sine minus 2.50. I'm going to cut the 0 off there, but this is the same thing. So that's the mod arg form, and that's the first part done for 3 marks. Now for part B, we have to find in terms of A, the complex number z1, z2. So this is just the multiplication of the brackets. So what we're doing here for part B is this here, z1 times z2. So it's going to be a double bracket like this. So it's going to be minus 4 minus 3i multiplied by a plus 7i. A plus 7i, like that. So that's going to give me what? So it's going to be minus 4 times 8, so minus 4a. I'm going to get minus 4 times 7i, so minus 28i. Minus 28i. I'm going to get minus 3ai. And what else am I going to get? I'm going to get plus 21, because this is minus 3i times 7i, so that would give me minus 21i squared, and I squared is minus 1, so minus 21 times minus 1 is plus 21, so plus 21. So let's simplify this, what we're going to get. So, in fact, we can't just simplify here, this is already in its simplest form, we just need to get it in the correct form now here. So it needs to be in the form C plus ID, so the imaginary parts needs to be on one side, and the real parts on the other. So doing that, that's going to give me 21 minus 4a. So we'll get the reals on this side, minus 4a. And I'm going to get plus, so I'm going to factor out I. So it's going to be I. So I can have it, so it's going to be in this, it's going to both be negative, should I say? So it's going to be minus 3a, minus 28. And that's part B done, so we've got it in the form C plus ID. So for C, we're given that Z1, Z2 is real, find the value of A. So if it's real, what that means is that the imaginary part here is equal to 0. So that means minus 3a minus 28 is equal to 0. So if this is equal to 0, we just need to solve it from here. So that means minus 3a is equal to 28 is equal to 28. So therefore a is equal to minus 28 divided by 3. So that's part C done. And then finally for part D, we'll do it over here. We're given instead that Z1, Z2 lies on the imaginary axis on the diagram diagram. So find the value of A. So if it lies on the imaginary axis only, what that means is that the real part is equal to 0. So if the real part is equal to 0, what that means is that 21 minus 4a is equal to 0. And this is why part B is important, and they give it you in this form. So if the real part's equal to 0, that means 21 minus 4a is equal to 0, which means 4a is equal to 21, which means a is equal to 21 divided by 4. And that's part D done as well. So that's the full question done. Hopefully that's okay. If you've got any comments though, guys, just leave them below.